Hello everyone, today we start a new chapter that is quadratic equation. In this chapter we learn about introduction of quadratic equation and then we learn about quadratic equation and after that we learn standard form of a quadratic equation and then we learn solution of a quadratic equation and after that we learn solution of a quadratic equation by factorization method. We also learn about solution of a quadratic equation by completing the square and then we learn about discriminant. We also learn about natures of root and then we learn some important point related to this chapter. But today we learn introduction of quadratic equation and then we learn about quadratic equation in detail and then we learn standard form of a quadratic equation. Introduction. A quadratic polynomial when equated to 0 resulting into a quadratic equation. Thus ax square plus bx plus c equal to 0 where a is not equal to 0 is a quadratic equation. A quadratic polynomial that is ax square plus bx plus c, when we write ax square plus bx plus c is equal to 0, then it becomes a quadratic polynomial. Ax square plus bx plus c, this is a quadratic polynomial. When we write ax square plus bx plus c is equal to 0, then it becomes a quadratic polynomial. Then it becomes quadratic equation. Now we take a real life example related to quadratic equation. The area of a rectangular garden is 750 meters square. The length of the garden is 5 meters more than its breadth. What should be the length and breadth of the garden? Let this is a rectangular garden and this is breadth and this length. It is given that length of the garden is 5 meters more than its breadth. Let breadth of the garden be x meter. That is b is equal to x meter or breadth is equal to x meter. It is given that length is 5 meters more than its breadth. When b is equal to 5 or we can say breadth is equal to 5, breadth is equal to x, then length is equal to x plus 5. X plus 5. And it is given that the area of rectangular garden is 750 meter and we know that the area of rectangular garden is length into breadth. Therefore we can write it as length into breadth is equal to 750 meter. Length into breadth is equal to 750 meter. The length is x plus 5 and breadth is x meter is equal to 750 meter. When x multiply x, it becomes x square. When x multiply 5, it becomes 5x is equal to 750. And we can say x square plus 5x is equal to 750 meter. When we transfer 750 in LHS, it becomes negative and we can write it as x square plus 5x minus 750 is equal to 0. Now this become a quadratic equation. X squared plus 5x minus 750 is equal to 0. This is a quadratic equation. Now we learn about quadratic equation in detail. Quadratic equation. A quadratic equation in variable x is of the form ax squared plus bx plus c equal to 0, where x represent a variable, or we can say an unknown, and a comma b comma c are real number where a is not equal to 0. Ax squared plus bx plus c equal to 0. This is a quadratic polynomial. In this polynomial, a, b and c are real number where a is not equal to 0 and x is a variable. When it is given that a is not equal to 0, when a is equal to 0, then this term becomes 0 and the remaining term is bx plus c equal to 0, and this become a linear. Then the polynomial, or we can say the equation, become linear equation. Now we take some example. 7x squared minus 6x plus 8 equal to 0. In this equation, the x square, or we can say this square term, this square, this make it a quadratic. This term make this equation quadratic. Another example of quadratic equation is 1 minus 20x plus 100x squared is a quadratic equation. Or we can say any equation of the form px equal to 0, where px is a quadratic polynomial, is called quadratic equation. Now we learn about standard form of a quadratic equation. Any equation of the form of px equal to 0, where px is a polynomial of degree 2, is a quadratic equation. But when we write the term of px in descending order, when we write the term of px in descending order of their degree, then we get the standard form of the equation. The standard form of the equation is ax squared plus bx plus c equal to 0, where a is not equal to 0. Here, this is ax squared. This term is 2 degree, and bx, this term is of 1 degree, and c, this term is of 0 degree. In this quadratic equation, the all terms are right in descending order. The degree of this term is 2, the degree of this term is 1, and the degree of this term is 0. That is the descending order of these degree. Therefore, ax squared plus bx plus c equal to 0. This is a standard form of quadratic equation where a is not equal to 0. Some example of standard form of quadratic equation is 4x square plus 5x minus 100 equal to 0. 21x squared plus 12x minus 110 is equal to 0. These are the example of standard form of quadratic equation. Now we take some more example of quadratic equation. 2x squared plus 5x plus 3 equal to 0. This is a quadratic equation. In this equation, when we compare this equation by the standard form ax squared plus bx plus c equal to 0, we get a equal to 2, b equal to 5 and c equal to 3. Clearly a, b, c all are real number. A, B, C all are real number and the degree of this term is 2, the degree of this term is 1 and degree of this term is 0. That is descending order. Therefore, this equation is a standard equation. This equation is standard quadratic equation. Now we take other example. X squared minus 3x equal to 0. When we compare this equation by ax squared plus bx plus c equal to 0. When we compare this equation by standard form of quadratic equation, we get a equal to 1, a equal to 1. We can write x square is equal to 1 multiply x square. Therefore, coefficient of x square, that is a, equal to 1 and b equal to minus 3. Where is c? So we can say c equal to 0. Now we take some other example. 5x minus 3 equal to 0. We can write this equation as 0 multiply x square plus 5x minus 3 equal to 0. When we compare this equation by standard form of equation, we get a equal to 0. When a equal to 0, we know that the standard form of a quadratic equation is ax square plus bx plus c equal to 0, where a is not equal to 0. And we also know that when a equal to 0, then it become a linear equation. Therefore, this equation is not a quadratic equation. This equation is not a quadratic equation because in this equation a equal to 0. That means this equation is not a quadratic. Hidden quadratic equation. As we saw before, the standard form of a quadratic equation is ax squared plus bx plus c equal to 0. We know that the standard form of a quadratic equation is ax squared plus bx plus c equal to 0. But sometimes a quadratic equation does not look like that. For example, x squared equal to 3x minus 1. When we transfer 3x minus 1 in LHS. We can write this equation as x square minus 3x plus 1. In this equation, a equal to 1, b equal to minus 3 and c equal to 1. All the values of a, b and c are real number and the degree of this equation is 2. Therefore, this equation x square minus 3x plus 1 equal to 0 is a quadratic equation. Now we take another example. 2 multiply w square minus 2w equal to 5. Now we expand bracket. When we remove this bracket, we get 2w square. When we multiply 2 with w, we get 2w square, and 2 multiply 2w minus 2w, we get minus 4w, and when we shift 5 in LHS, it become minus 5, and the equation become 2w square minus 4w minus 5 equal to 0, where a equal to 2, b equal to 4 and b equal to minus 4 and c equal to minus 5, and the variable is 2 in this, the variable is w in this equation. In this equation, variable is w, or we can say this quadratic equation is in the form of w. Now we take another example. Z multiply z minus 1 equal to 3. When we remove this bracket, or we can say when we multiply z into z, it becomes z square. Z multiply minus 1, it become minus z equal to 3, or we can write it as z square minus z minus 3 equal to 0, where a equal to 1, b equal to minus 1 and c equal to minus 3. These three examples are of hidden quadratic equation. Check whether the following are quadratic equation. Whole square of x plus 1 equal to twice of x minus 3. We know that whole square of x plus 1 is x square plus 2x plus 1 is equal to 2 multiply x, it become 2x. 2 multiply minus 3, it become minus 6. We can write it as x square plus 2x plus 1. When we transfer 2x in LHS, it become minus 2x, and minus 6 in LHS, it become plus 6 equal to 0. Minus 2x is cancelled plus 2x, and we get x square plus 1 plus 6, it become 7, or x square plus 7 equal to 0. Now we take another example. X minus 2 multiply x plus 1 equal to x minus 2 multiply x minus 1 multiply x plus 3. First we multiply x in second bracket, and then we multiply minus 2 in second bracket. Now we multiply x in x with x, it become x square. X multiply plus 1, it become x. Minus 2 multiply with x, it become minus 2x. minus 2 multiply with 1, it become minus 2, equal to, now we multiply x with second bracket, x multiply x, it become x square, x multiply 3, it become 3x, minus 1 multiply x, it become minus x, minus 1 multiply 3, it become minus 3. We can write it as x squared minus plus x minus 2x. We get minus of x and minus 2, and we transfer these all terms in LHS. It become minus x square. By transferring in LHS, it become minus x square plus 3x. In LHS, it become minus 3x minus x. In LHS, it become plus x minus 3. In LHS, it become plus 3, equal to 0. Now plus x squared and minus x squared is cancelled. Minus x and minus 3x, it become minus of 4x, minus 2 and plus 3, it become plus 1 and plus x, equal to 0. Minus 4x plus x, it become minus of 3x plus 1, equal to 0. Now we get a equation minus 3x plus 1 equal to 0. In this equation, there is no term of x square. Therefore, we can say that this equation is not a quadratic equation. Now we take another example. X minus 3 multiply with 2x plus 1 equal to x multiply x plus 5. Now we multiply x with 2x, we get 2x square, x multiply plus 1, we get plus x, minus 3 multiply 2x, it become minus 6x, minus 3 multiply 1, it become plus 3, equal to x multiply x square, and x multiply plus 5, it become plus 5x. Now we transfer these all term in LHS. We get 2x squared minus plus x and minus 6, it become minus of 5x plus 3. When we transfer x squared in LHS, it become minus x squared, and plus 5x in LHS, it become minus 5x, equal to 0. Twice of x squared and minus x squared, it become x squared minus 5x and minus 5x, it become minus of 10x and plus 3, equal to 0. Now in this equation is in the form of ax squared plus bx plus c equal to 0. Therefore, this equation is a quadratic equation. Next is x squared plus 3x plus 1 equal to whole square of x minus 2. We can write it as x squared plus 3x plus 1 equal to whole square of x minus 2 is x squared minus 4x plus 4. Now we transfer these all term in LHS. We get x squared plus 3x plus 1, x squared in LHS, it become minus x squared, minus 4x in LHS, it become plus 4x, and plus 4 in LHS, it become minus 4. X squared and minus x squared is cancelled, plus 3x and plus 4x, it becomes 7x, plus 1 and minus 4, it become minus 3, equal to 0. Then the equation is 7x minus 3, and clearly this equation is not a quadratic equation because in this equation the ax square term is not in this equation. Now what we learn today? We learn quadratic equation. A quadratic equation is of the form of ax squared plus bx plus c equal to 0, where a is not equal to 0. Ax squared plus bx plus c equal to 0, where a is not equal to 0 is a quadratic equation. Or we can say that a 2-degree equation is a quadratic equation. And we can say 1 minus 7x plus 3x squared equal to 0 is also a quadratic equation because this equation is a 2-degree equation. Now we learn in this about standard form of a quadratic equation. We know that the standard form of a quadratic equation is ax squared plus bx plus c equal to 0, where a is not equal to 0 is a standard form of a quadratic equation. Or we can say that the all terms of quadratic equation write in descending order of their degree, then the equation become standard form of quadratic equation. Here there is 2-degree term and this term of 1 degree and this term of 0 degree. Or we can say these all terms are writing in descending order. Therefore, this is the standard form of quadratic equation. Represent the given situation in the form of quadratic equation. The product of two consecutive positive integers is 306. We need to find the integer. In this problem, we have to represent this situation in the form of quadratic. The product of two consecutive positive integers. We know that the two consecutive positive integer is regular number, that we can say if one of the consecutive positive integer is x, then the other is x plus 1, and it is given that the product of two consecutive positive number is 300x. Therefore, x multiplied with x plus 1 is equal to 306, and x multiply x, it become x squared, and x multiply 1, it become plus 1 plus x equal to 306. Now we transfer 306 in LHS, it become x squared plus x minus 306 equal to 0. This is of the form of quadratic equation.